Okay, we'll go for the next question then. See, 3 charges plus 5 microcoulomb, plus 10 microcoulomb and minus 10 microcoulomb are placed at 3 vertices of an equilateral triangle ABC in air. So, plus 5 microcoulomb will be placed at A, plus 10 will be placed at B and minus 10 will be placed at C. We have to find out what is the force acting on a charge which is placed at A. Okay, so this is an equilateral triangle now. And we have named the equilateral triangle as A, B and C. So the name of the equilateral triangle is ABC. There are 3 charges given. First charge is placed at A and it is plus 5 microcoulomb. Second charge is placed at B. Second charge is placed at B and it is plus 10 microcoulomb. And third charge is placed at C and it is minus 10 microcoulomb. So these are the 3 charges given. They have to be placed at A, B and C. Okay, I will place the charges here. This is plus 5 microcoulomb. This is plus 10 microcoulomb and this one is minus 10 microcoulomb. So these are the 3 charges placed at the 3 vertices of an equilateral triangle. All the sides of the triangle are of equal length, that is 5 centimeter, 5 centimeter and 5 centimeter. So it is an equilateral triangle. Equilateral triangle means we know that all the sides will be equal, all the angles will be equal. Each angle will be of 60 degree because it is an equilateral triangle. Okay. See, what is the question? We have to find out what is the force acting on a charge which is placed at A. It means we have to find out the force acting on plus 5 microcoulomb. That is the thing what we have to calculate. Okay. See, we know that on any charge, how many number of forces will be acting? How many number of electric charges will be in its neighborhood? Those many number of forces will be acting on it. See, in the neighborhood of plus 5 microcoulomb charge, there are 2 charges. One is plus 10 microcoulomb and another one is minus 10 microcoulomb. Other than these 2, there are no any charges in its neighborhood. Okay, that's why on plus 5 microcoulomb, now 2 forces has to be acting. One is due to plus 10 microcoulomb, another one is due to minus 10 microcoulomb. Okay, then what kind of forces this should be? See, the force acting on plus 5 microcoulomb due to plus 10 microcoulomb should be repulsive force. It should be repulsive force because this is also positive and this is also positive. Hence, this force acting in between these 2 charges must be repulsive. Repulsive means they should be acting away. And the force acting on plus 5 microcoulomb due to minus 10 microcoulomb should be attractive because this is positive and this is negative. If they are unlike charges, there will be an attractive force acting in between them. If they are like charges, there will be a repulsive force acting in between them. Okay, we'll draw the direction of these forces now. First, we'll draw the direction of these forces. See, the force between plus 5 microcoulomb and plus 10 microcoulomb will be repulsive. Repulsive means it should be acting away. And that force should be acting along a straight line joining these 2 charges only. Okay, so the force acting on plus 5 microcoulomb due to plus 10 microcoulomb will be in this direction. This is the direction of the force acting on this. Okay, I will name this as F1. F1 means it is the force acting on plus 5 microcoulomb due to plus 10 microcoulomb. It is repulsive. Okay, so that force should be shown along the line joining the 2 charges only. I cannot show it in this way or in this way. It has to be shown along the straight line joining the 2 charges only. Okay, this is the first force acting on plus 5 microcoulomb. One more force is due to minus 10 microcoulomb. What type of force it has to be? It has to be attractive because this is negative, this is positive. Attractive means I cannot show it in this way now. I should show it towards each other. And it should also be along the line joining the 2 charges only. So that attractive force will be along this direction. I am showing it here and I will name this force as F2. Okay, so this is F2 force now. Hence, we got to know that there are total 2 forces acting on this charge plus 5 microcoulomb. See, here this is a straight line now. BAF1. What is this? This is a straight line. Straight line means how much will be the angle? What will be the angle of the straight line? 180 degree. Okay, in that 180 degree, this angle we already know. This is 60 degree because it is an equilateral triangle. All angles will be 60 degree. Okay, out of 180, if I remove 60, how much angle will be remaining here? It will be 120 degree. So we got to know what is the angle between F1 and F2. Angle between F1 and F2 is 120 degree. Okay, so we got to know the two forces acting on the charge plus 5 microcoulomb, the angle in between them of F1 and F2, with how much angle they are acting in between them. We got to know these two forces and the angle between them. Now what we have to do? We have to find out the resultant force on this. Right? We have to find out the resultant. Fine? Okay, so we'll find out the resultant of these two forces now. It means the total force, net force acting on plus 5 microcoulomb. Okay, now see, first one is force acting on plus 5 microcoulomb charge due to plus 10 microcoulomb charge is given by F1. We know that F means it is Coulomb's force and its equation is 1 by 4 pi epsilon naught Q1 into Q2 divided by R square. What is the value of 1 by 4 pi epsilon naught? 9 into 10 to the power 9. Q1 into Q2. This is F1. F1 means force acting between plus 5 and plus 10. So Q1 into Q2 means 5 into 10 to the power minus 6 and 10 into 10 to the power minus 6. These both are microcoulombs. That's why I am taking it as 10 to the power minus 6. 10 to the power minus 6 means microcoulomb. Okay, divided by R square. R square means square of distance between them. How much is the distance? 5 centimeter is the distance between these two charges. So I will write here 5 centimeter. Let us take it in meter. 5 into 10 to the power minus 2 whole square. Okay. So we'll simplify this now. Simplifying this, we will get 9 into 10 to the power 9. So 5 into 10 will be 50. 10 to the power minus 6. 10 to the power minus 6 will be 10 to the power minus 12. Divided by 5 square. 5 square is 25 into 10 to the power minus 2 into 2 will be minus 4. Okay. So this will be 25 ones are, 25 twos are, minus 4 and minus 4 will go from this. Here the remaining thing will be minus 8 now. In minus 12 if I remove minus 4, I will get 10 to the power minus 8. So 10 to the power minus 8 and 10 to the power plus 9. How much will be the remaining thing? It will be 10 to the power plus 1. So 9 into 2 will be 18. 9 into 2 will be 18. Here 10 raised to the power minus 8 will be remaining. 10 raised to power minus 8 and 10 raised to power plus 9 means it will be equal to 10 raised to power plus 1. So what will be the force? Force will be 180 Newton. So this much is the force acting on plus 5 microcoulomb due to plus 10 microcoulomb. So F1, we got to know what is the value of F1 now. F1 is 180 Newton. Along which direction it is acting? It is acting along BA. I will write the direction also here. Okay, if you want you can write the direction also here along BA. So this is the direction of the force acting on it. Okay, we got to know the value of one force which is acting on the charge plus 5 microcoulomb. Second force F2 is the force acting by minus 10 microcoulomb on plus 5 microcoulomb. See, here I will calculate the force now. Force acting on plus 5 microcoulomb charge due to minus 10 microcoulomb charge. Okay, so that force is given by F2. It is given by F2. See, F1 was the force. F1 was the force between plus 5 and plus 10. F2 is the force between plus 5 and minus 10. See, both the charges are same in magnitude. Polarity is different. Here it is plus, here it is minus. Polarity is different, but magnitude is same. 5, 10, 5, 10. Okay, it means Q1 and Q2 are same. Here also Q1 and Q2 are 5 and 10. Here also Q1 and Q2 are 5 and 10. Here also the distance between Q1 and Q2 is 5 cm. Here also the distance between Q1 and Q2 is 5 cm. It means charges are same, distance is same. If charges and distance are same, then what has to be? Force has to be same. Because we know that F is directly proportional to product of magnitude of two charges and inversely proportional to the square of distance between them. So if product of magnitude of charges and distance, these both are same, then force has to be same. Yes, that's why here we have got F1 is equal to 180 Newton means F2 is equal to, it will also be 180 Newton. If you want, you can calculate it. By calculating it also we will get the same thing. 9 into 10 to the power 9. Q1 into Q2. Q1 into Q2 means plus 5 minus 10. We have to take only magnitude here. Don't take the signs here. You cannot take it as plus 5 into minus 10. We should take it as 5 into 10 only. Okay, only magnitude we have to take. So it will be 5 into 10 to the power minus 6 and 10 into 10 to the power minus 6 divided by what is the distance? Distance is 5 cm. 5 into 10 to the power minus 2 whole square. Here I am taking it as 5 into 10 to the power minus 2 because here it is in centimeter. This one is in centimeter. We have to take it in meters. Yes or no? That's why 5 into 10 to the power minus 2 whole square. Again, it is the same thing. Yes or no? So final answer F2 will be equal to 180 Newton only. This will also be 180 Newton only. Okay. So we got to know two forces now. What is the direction of F2 now? Direction of F2, here I have shown it. Okay, it is acting from A to C, along A to C. So I will write the direction here, that is along AC. Fine. So these are the two forces, F1 and F2 are the two forces acting on charge plus 5 microcoulomb. Okay, we got to know the two individual forces acting on it. Next we have to find out the resultant force acting on it, net force. Okay, we'll go for the net force now. So the net force acting on charge, net force acting on charge plus 5 microcoulomb is, see, how to calculate the net force now? How to calculate the net force? Two forces are there, F1 and F2. F1 is also 180 Newton and F2 is also 180 Newton. So both the forces are equal in magnitude, 180 Newton, 180 Newton. But directions are different. One is acting along BA, another one is acting along AC. So two equal forces are acting in different directions such that the angle between them is 120 degrees. Okay, we got to know there are two vectors here, and the angle between the two vectors is 120 degrees. So when two vectors are acting at the same point, here both the vectors are acting at the same point A. So when two vectors are acting at the same point with a certain angle between them, what formula we have to use to calculate the resultant force? Resultant force we already derived it in first year, that is F is equal to, see, resultant force R will be equal to root of P square plus Q square plus 2PQ cos theta. Yes or no? So this is the resultant vector of two vectors P and Q. If there are two vectors P and Q acting at a certain angle between them, then the resultant R is given by this equation. This equation will give you how to calculate the resultant of the two vectors which are acting at a certain angle between them. Okay, here we are having two vectors. What are those two vectors? F1 and F2 are the two vectors. What is the angle between F1 and F2? 120 degrees. Okay, that's why we have to calculate the resultant force now, net force. So that net force means I will take it as F. This is the resultant force. Okay, so resultant force. This resultant force can be calculated by using this formula only, and I will write it as F1 square plus F2 square plus 2 F1 into F2 into cos theta. So this is the formula to find out the resultant force. So same formula I am using. We know the value of F1, F2, we know the value of theta, that is 120 degrees. We'll substitute the values. Okay, so final answer is 180 Newton. This is the resultant force acting on that. Resultant force acting on the charge plus 5 microcoulomb. Okay, in which direction this will be acting now? This resultant force 180 Newton will be acting in which direction? See, the two individual forces which are acting on plus 5 microcoulomb are 180 Newton and 180 Newton. Angle between these two is 120 degree. So if two vectors which are acting at a point with a certain angle between them are equal in magnitude, then the resultant vector will be exactly at the middle. Exactly at the middle means it has to, that resultant vector has to divide the angle between the two vectors in two equal halves. It means this 120 degree has to be divided into 60 and 60. So the resultant force, what we have got, 180 Newton, that resultant force 180 Newton will be acting at an angle 60 degree from F1 as well as at an angle 60 degree from F2. Okay, so at this point it will be acting. So this is the resultant force acting on the charge plus 5 microcoulomb. Okay, in case if you want to calculate it mathematically by using the formula, we'll calculate the direction also now. At how much I told you that this will be acting at 60 degree from F1 and 60 degree from F2. Which one? Resultant force. Resultant force will be acting at 60 degree from F1 and at 60 degree from F2. Okay, that we will calculate mathematically. Again, we'll use the first year formula. What is that first year formula? See, in first year, we will use the formula called as tan alpha is equal to Q sin theta divided by P plus Q cos theta. This is the formula which we have used to calculate the angle. This is to calculate the resultant. Okay, this is to calculate the angle. Okay, so this formula, by using this formula, we will calculate at how much angle it will be acting. Okay, I will name that angle as alpha now. Okay, let this angle be alpha. Which one? Angle between F1 and F. Fine. So we have to calculate this alpha now. Okay. So we'll calculate that alpha by using this formula only. See, tan alpha is equal to value of F2 is 180, value of sine 120 degrees root 3 by 2 divided by 180. F1 is 180 plus F2 is also 180 into cos 120 degree means it will be 1 by 2. Let's simplify this now. Okay. See, 2 ones are, this is 2 90s. 180 means 2 90s. So minus into plus will be minus. Fine. So 180 minus 90, it will be equal to 90 only. So I will write here. See, this can be written like this now. 2 ones are 2 90s are. This is 2 ones are 2 90s. So in the numerator, the remaining thing is, here I will take, in the numerator, the remaining thing is 90 root 3 divided by, here the remaining thing is 180 minus 90. 180 minus 90 means it will be 90 only. So it is 90 root 3 divided by 90. 90 and 90 will get cancelled. It will be root 3. Okay, we got tan alpha is equal to root 3. If tan alpha is equal to root 3, then alpha will be equal to 60 degrees. So this is the angle. It means if this is 60, then this will be 60 because total is 120 here. So this is 60 and this will also be 60. Hence, that resultant force is dividing 120 degree into 2 equal halves. Why it is dividing into 2 equal halves? Because both the vectors F1 and F2 are equal in magnitude. Right? So this is the final answer. We'll go for the next question then. 4 point charges plus 2 microcoulomb, minus 5 microcoulomb, plus 2 microcoulomb and minus 5 microcoulomb are placed at 4 corners of a square of side 10 centimeter. What will be the net force acting on a charge of 1 microcoulomb placed at the center of the square? So this is the question. See, total 4 charges are given. First one is placed at A, that is 2 microcoulomb. Another one is placed at B, that is minus 5 microcoulomb. Third one is placed at C, that is also plus 2 microcoulomb. And at D, this is also minus 5 microcoulomb. So these are the 4 charges placed at the 4 vertices of a square. Okay. So at A, it is QA is equal to 2 microcoulomb. At B, it is QB equal to minus 5 microcoulomb. At C, it is QC is equal to plus 2 microcoulomb. At D, that is QD equal to minus 5 microcoulomb. So these are the 4 charges placed at the 4 corners of a square whose name is A, B, C, D, and the side of the squares are 10 centimeter each. Okay. See, at the center of the square, it means at this point, 1 microcoulomb charge will be placed. So there is a charge called 1 microcoulomb placed at the center of the square. What we have to find? We have to find what is the net force acting on this 1 microcoulomb charge. Okay. See, basically we know that at the neighborhood of charge, how many neighboring charges will be there? Those many number of forces will be acting on that charge. So on this 1 microcoulomb charge, there will be 4 forces acting on. One is due to the charge at A, second one is due to the charge at B, third one is due to the charge at C, and fourth one is due to the charge at D. So due to all 4 charges, there will be 4 forces acting on this charge 1 microcoulomb. So what should be the direction of these forces now? First we'll draw the direction of these forces. See, first force will be in between charge at A and charge at O. I will name this center as O. Okay, so the force between these two. This is plus 2 microcoulomb, this is plus 1 microcoulomb. It means both are like charges, plus, positive and positive. So what kind of force should be there? Repulsive force. So repulsive force means it should be shown in this direction. This is the direction of the force. I will name this as F1. Okay, F1 means it is force due to charge which is placed at A. Okay, next, or let us call it as FA only. FA means it is force due to the charge at A. Okay, so this is the force acting on 1 microcoulomb charge due to the charge which is at A. I have shown it in this direction because both are positive, that will be a repulsive force. Next one. Force between charge at O and charge at B. See, charge at O is plus 1 microcoulomb, charge at B is minus 5 microcoulomb. It means both are opposite charges. then what kind of force should be there? Attractive force. Attractive means it should be acting in this direction. I cannot show it away now, I should show it towards. That's why that attractive force will be acting in this direction. I will name it as FB. Okay, next, third force. Third force is due to the charge at C. So the force between charge at O and charge at C, both are like charges, +2, +1. It should be repulsive. Repulsive means I should show it in this direction. So I will name it as FC. This is third force. Fourth force, due to the charge at D. See, the force between charge at D and charge at O. Look at the charges. This is positive, this is negative. So there should be attractive force. Attractive force means it should be acting towards. That's why that force I will show in this direction. This is the direction of the force now. I will name it as FD. So total 4 forces are acting on this charge at, that is FA, FB, FC and FD. 4 forces are acting in along these directions. Now what we have to do, we have to calculate the magnitudes of all these forces, FA, FD, FC, FD. Magnitude of all these forces. Okay, so we'll go on calculating the magnitude of all these forces now. See, the first force, we'll calculate FA. FA means it is the force between charge at A and charge at O. Okay, so it will be 9 into 10 raised to 9 Q1 into Q2. What is Q1 here? 2 microcoulomb. What is Q2 here? 1 microcoulomb. So 2 into 10 to the power minus 6 into 1 into 10 to the power minus 6 divided by square of distance between them. What will be the square of distance between them? 10. 10 by root 2. 10 is in centimeter, we'll take it in meter. 10 into 10 raised to minus 2 divided by root 2 whole square. So simplifying this, we will get it as 3.6 Newton. Okay, so this is the force FA. Next, we'll go for the force FB. FB. See, FB will also be equal to 9 into 10 raised to 9. And what are the Q1 and Q2 values now? FB. Here is FB. FB means it is force between 1 microcoulomb and minus 5 microcoulomb. Okay. So Q1 means 1 microcoulomb, Q2 means 5 microcoulomb. So it should be 1 into 10 to the power minus 6, 5 into 10 to the power minus 6 divided by, the distance will again be same, 10 into 10 to the power minus 2 divided by root 2 whole square. It will be 9 Newton. Okay, simplifying this. Similarly, see FC. See, FA was force between 2 microcoulomb and 1 microcoulomb. FC is also the force between 2 microcoulomb and 1 microcoulomb. Charges are same. And however, distance of each charge from the center of the square will be same only. Distance of each charge from the center of the square will be same only. If the charges are same, distance is same, then force has to be same. That's why FC means it will be equal to FA only, because FA is also force between 2 microcoulomb and 1 microcoulomb. FC is also the force between 2 microcoulomb and 1 microcoulomb. So FC will be equal to, FA will be equal to 3.6 Newton only. Similarly, FD means it is force between 1 microcoulomb and minus 5 microcoulomb. So what FD should be equal to? FD should be equal to FB. Okay, that's why FD equal to FB equal to, it will be 9 Newton. Okay, so we got to know the values of all the forces now. Look at the directions. FB and FD are equal. FB and FD are equal, but they are opposite in directions. Yes, sir? They are opposite in directions. That's why I can write it like this: FB is equal to minus FD. See, FA and FC are equal, but they are opposite in direction. One is acting in this direction, another one is acting in this direction. They are acting along same directions only, opposite directions along the same line. So I can write FA equal to minus FC. So what happens now? The forces will get cancelled. They are equal and opposite in direction. So FD and FB will get cancelled. FA and FC will get cancelled. Then what will be the resultant? Resultant has to be 0. So the resultant force on 1 microcoulomb charge is F is equal to FA plus FA minus plus FA plus FB minus FC minus plus FC plus FD. Okay, I'm adding all of them now. See, FA plus FB. Okay, FC means what it is? FC means it will be equal to minus FA, or we can write it like this. Instead of that, We'll substitute the values here directly. See, what is FA? FA means it is minus FC. What is FB? FB means it is minus FD. Okay, plus FC plus FD. So plus minus FC plus FC minus FD plus FD. What will be the resultant? Resultant will be 0 Newton. So the net force acting on the 1 microcoulomb charge which is placed at the center is 0 Newton.